Imagine a force so powerful that it can carve entire mountains, create deep valleys, and reshape continents without a single explosion. That force is ice. How can something as soft as snow eventually become powerful enough to cut through solid rock? The answer lies in glaciers. The breathtaking valleys of Kashmir, the majestic fjords of Norway, and some of the world's sharpest mountain peaks all have one thing in common. They were sculpted by moving ice. Thousands of years ago, giant rivers of ice transformed Earth's surface. The evidence is still visible today in the mountains, valleys, and lakes around us. What if I told you that glaciers act like giant bulldozers, sandpaper, and transport trucks, all at the same time? By the end of this video, you'll understand exactly how. Erosional landforms. Cirque, Corrie, or Coombe, a bowl-shaped depression formed at the head of a glacier. Formation. Snow accumulates in a mountain hollow. Ice erodes the area through plucking and abrasion. A deep, amphitheater-shaped basin develops. Features: steep sides, deep basin. Often contains a small lake after the glacier melts. Example, Red Tarn in England. A lake occupying a cirque is called a tarn lake. Arete, a sharp, knife-edged ridge between two cirques. Formation. Two glaciers erode opposite sides of a mountain. The ridge between them becomes narrow and sharp. Appearance. Looks like a mountain knife edge. Truncated spurs. Ridges of rock that previously jutted into a V-shaped valley. They are bulldozed or sliced off by the main glacier as it carves a straighter, wider path. Horn Peak, pyramidal peak. A pointed mountain peak is formed when three or more cirques erode a mountain from different sides. These sharp, steep-sided peaks are created by the headward erosion of the cirques that converge at a central point, such as the Matterhorn. Example, Matterhorn. Matterhorn is the world's most famous horn peak, U-shaped valley, glacial trough. A valley widened and deepened by a glacier. Formation. River valleys are originally V-shaped. Glacier widens and deepens them. Valley becomes U-shaped. Characteristics: flat floor, steep sides. Hanging valley. A smaller valley located above the main glacial valley. Tributary valleys that sit at a higher elevation than the main glacial trough. They often end abruptly at the main valley, producing dramatic waterfalls. Formation. The main glacier erodes deeper than the tributary glaciers. After melting, the tributary valley remains hanging. Feature. Often forms waterfalls. Fjord. A deep, narrow sea inlet is formed when a U-shaped valley is flooded by seawater. These deep, U-shaped glacial valleys, which can be completely submerged or partially filled with ocean water, are commonly found in coastal regions of Norway and New Zealand. Examples. Norway's fjords are world famous. Fjords are among the deepest coastal landforms on Earth. Roche Moutonnet. This is an asymmetrical rock hill shaped by glacier movement. It features asymmetrical bedrock outcrops with a smooth, gently sloping, striated stoss side, which faces up ice, and a jagged, plucked lee side, which faces down ice. Features: smooth side facing glacier movement. Rough side opposite glacier movement. Indicates direction of glacier flow. Glacial deposition. What is glacial deposition? When glaciers melt, they deposit the materials they carry. These materials are referred to as till, which is an unsorted mixture of clay, sand, gravel, and boulders. Depositional landforms. Glaciers, vast sheets of ice that slowly slide over the land, have a significant impact on the landscape. They cover large areas, such as plains adjacent to mountains, and flow down valleys between mountain ranges. Driven by gravity, glaciers move gradually, altering the terrain as they advance. As they travel, glaciers deposit sediment and sculpt distinctive landforms, contributing to the diverse and captivating features known as glacial depositional landforms. Moraine. Accumulation of glacial debris. Types. Lateral moraine, deposited along glacier sides. Medial moraine, formed when two glaciers join. Terminal moraine, deposited at the glacier's furthest advance. Ground moraine, deposited beneath the glacier. The terminal moraine marks the maximum extent of a glacier. Drumlin, an elongated hill made of till. Shape, looks like an inverted spoon or half egg. Characteristics: smooth side faces the glacier, tapered side points away. Importance: shows direction of ice movement. Esker, a long, winding ridge of sand and gravel. Formation: deposited by streams flowing beneath glaciers. Appearance: looks like a natural railway embankment. Kame. A kame is a steep, mound-like hill or ridge composed of stratified sand, gravel, and till. These landforms are created by glacial meltwater and are typically found in areas that were once covered by glaciers or ice sheets. Formation: deposited by meltwater on glacier surfaces. Outwash plain. An outwash plain, also called a sander, is a broad, gently sloping plain formed by sediments deposited by meltwater streams at the terminus of a glacier. As the ice melts, water carries and sorts materials, leaving heavier gravels near the glacier and finer silts further downstream. Material: sand, gravel, silt. Feature: materials are sorted by water, kettle hole, and kettle lake. A kettle hole is a shallow, bowl-shaped depression formed when a buried block of stagnant glacial ice melts. A kettle lake is simply a kettle hole that has filled with water by intersecting the local water table. Formation: a large ice block gets buried in sediment. Ice melts later. Depression forms, if filled with water from kettle lake. Erratics. An erratic, usually called a glacial erratic, is a large rock or boulder that has been transported and deposited by a glacier to a new location, where it rests on bedrock of a completely different type and origin. Importance: evidence of past glaciation. Difference between till and outwash. Till and outwash are two types of glacial deposits formed in different ways. Till is deposited directly by glacier ice, so it contains a random mixture of large and small particles without any sorting. In contrast, outwash is deposited by meltwater flowing from glaciers. As the water carries and deposits sediments, they become sorted by size, forming distinct layers of sand, gravel, and other materials. River valleys and glacial valleys differ in their shape and formation. River valleys are typically V-shaped, narrow, and have a steep, pointed bottom because they are carved by the continuous flow of river water. In contrast, glacial valleys are U-shaped, much wider, and have a broad, flat bottom. They are formed by the slow movement of massive glaciers, which erode the land evenly, creating wide valleys with steep sides. Glaciers are among the most powerful natural forces on Earth, slowly shaping mountains, valleys, and landscapes over thousands of years. Understanding their role helps us appreciate how our planet continues to evolve. Follow Eduscope Planet for more simple, engaging, and informative geography lessons that make learning easy and exciting. Until next time, keep exploring, keep learning, and keep growing with Eduscope Planet.